Okay, so these are some more think, pair, share problems. Give these a try. Okay, let's look at the first one. So, customer preference for drone deliveries. Test the claim that the proportion of consumers not comfortable with drone deliveries is greater than 0.5. All right, so test the claim. That's good. We're going to be doing a hypothesis test. Um, that the proportion of customers, okay, proportion of customers. Now, this is referring to all customers, and we're dealing with a proportion, so that's going to be the letter P. And it says is greater than 0.5. So we've got P greater than 0.5. All right, so let's look at this on a number line. So we've got 0.5 on a number line, and then we've got greater than 0.5. So that means it's not going to include 0.5 and it's greater than it. So this is P greater than 0.5. So what is the complement to that? It's going to be equal to 0.5 and less than. So it's going to be less than and equal to 0.5. Okay. And I keep forgetting this. I gotta make sure I don't forget. Our original claim was this one. There we go. Now between the two, which is our null and which is our alternate. So the null hypothesis is the one with an equals in it. So this one is our null, which means the other one has to be the alternate hypothesis. And because this is greater than here, right, make an arrow out of it. And so we're going to be dealing with a right-tailed distribution if we were to continue on with this hypothesis test. All right, let's look at the next one. So we want to test if college students take less than 5 years to graduate from college on the average. Okay, so the wording is here is a little bit out of order. So we've got less than, and we've got 5. And so we're looking at like average years. Okay, so that's going to be population. So we're going to have mu less than 5. And because I've been getting away from this, I want to make sure to label this as the original claim first. All right, what's the complement to that? Well, if this one is less than, then the other one's going to be greater than or equal to. And between the two of those, the null has an equality in it. The alternate does not. And because of this less than, that means we're going to be dealing with a left-tailed distribution. All right, let's go to the last example. So in an issue of US News and World Report, an article on school standards stated that about 50% of students in France, Germany, and Israel take advanced placement exams, and 33.3% of students pass. The same article stated that 6.6% of US students take advanced placement exams and 4.4% pass. Test if the percentage of US students who take advanced placement exams is more than 6%, 6.6%. So now this one, it's a little harder, to discriminate what, what the null or alternate hypothesis is going to be because so much has been thrown at us. But what's kind of an indicator is it says test. So test the percentage of US students. So this is referring to a proportion. Then it says is more than 6.6%, which is 0.066. So we've got the mathematical inequality P greater than 0.066. And before I forget, let's make that our original claim. All right, so what's going to be the complement of that? Well, if this is greater than, then the complement will be less than or equal to. And the null hypothesis always has an equality in it, and the alternate does not. But the alternate tells us the distribution tailness, left tail, right tail, or two-tailed. So this would be, an arrow pointing to the right. So we're going to be dealing with a right-tailed distribution in the end. Okay, so that concludes those three examples. Let me know if you have any questions.